Algebra 2 students. Mrs. Myers here. These are the notes for lesson 15, day 2. If you have the ability to get this printed from Google Classroom, please do so. If not, and just put all this on regular loose paper, okay? So you're going to be asked to make a graph for each polynomial function below, and I'm going to ask you to, of course, still graph it by using the zeros of it, which are the x-intercepts, but this time we're going to use the multiplicities of the zeros to get the behavior of the graph with respect to each x-intercept, and we're also going to talk about what the ending behaviors of the graph should be, and that'll again be based on degree and leading coefficient like we talked about today during class with respect to yesterday's notes, okay? So anyway, let's get started. First thing I want you to take stock of before we even start doing numbers 1 and 2 is the different forms that numbers 1 and 2 are presented to you in. Number 1 is presented to you in factored form already, which means we are ready to go with getting the zeros and knowing the multiplicities of each factor. Therefore, that gives you the multiplicity of each zero. But number 2 is not in factored form, and we need to get it into factored form. Okay, so for number 1, we're going to just start by writing the zeros down, okay? And the zeros come from setting each of the factors equal to 0. Why? Because the zeros are found by letting y be 0. So if we just set each factor equal to 0, okay? So we just come here and we'd go set the factor of x plus 2 equal to 0, set the factor of x minus 1 equal to 0, and set the factor of x minus 3 equal to 0, then we can clearly see that our three zeros are an x value of -2, an x value of +1, and an x value of +3. Now, what is each multiplicity, right? So this multiplicity right here of this 0 is only 1. Why? Because the factor that it came from is only being raised to the first power. Likewise, this 0 of +3 is only a multiplicity of 1 because the factor that it came from is only being raised to the first power. But this multiplicity is 2 because the power on that factor of x minus 1 is a power of 2, so that multiplicity is a 2. Now that's going to tell us the behavior of the graph with respect to the following x-intercepts. So those x-intercepts will be, right, -2, 0, because the 0 is -2, 1, 0, because we have a 0 of 1, and 3, 0. So I'm going to come to my graph, and I'm just going to, at an x value of 3, put a dot, so I know I have an x-intercept there. At an x value of 1, I'm also going to put a point because I know I have an x-intercept there as well. And finally, at an x value of -2, right, I'm going to put another x-intercept. So based on lesson 14 material, okay, so based on lesson 14 material, I would take this graph, and you don't have to write this down, but I would take this graph and I'd say, all right, so I've got an interval of x's that are greater than 3, okay? I've got an interval of x's that are between 1 and 3. I've got an interval of x's that are between -2 and 1. And lastly, I've got an interval of x's that are less than -2 that I should pick a test value for. And I should see what my function evaluates to be at that x value. Because if the function evaluates to be a positive number, the graph will be above the x-axis. If the function evaluates to be a negative number, the graph will be below the x-axis. So let me just, again, pick a test value and see what happens, okay? Now, you can still absolutely do that, and in fact, for the quiz next week, I'm going to ask you to do that, but I'm also giving you some other techniques now as to how we can still get the graph without having to do that. Or if we do everything, it'll just be a nice checks and balance with each other, okay? So we're going to start by getting the behavior of the graph at the ending of it, meaning for all the x's that are greater than 3, so as the graph just keeps going to the right more and more and more as x's keep getting more and more positive, right? As the x's approach positive infinity, what will the y's do? What will this ending behavior on the right be? And we're also going to take a look at this part of the graph, meaning for the x's that are less than -2, right? What will that ending behavior be? So as the x's get more and more negative, what are those y's going to do? All right. So what we need to think about is for this function, what would be the very first term? Well, I see that I've got an x here. I've got an x squared, and I've got another x. So if we multiply all those x's together, that's going to be an x to the 4th. Now you see how there's this extra negative hanging out right here? that means that I'd have to, of course, have that extra negative hanging out there. Now, the next term is going to be like something x at a third, something x at a second for the next term, something x, a constant, whatever. But I don't care about all that. It doesn't really matter what the rest of the polynomial looks like. I really just care about this very first term right here, okay? The term that's going to have the highest exponent and what it's, what the number in front of that term is, because that's going to tell me my ending behaviors. Actually, let me write this a little bit lower on the paper. Okay, so again, ending behaviors. Okay, so what is my degree and what is my leading coefficient? So the degree is the highest exponent, right? So the degree is 4. Okay, that's a degree 4 polynomial. And what category do we give that degree? Well, we have only 2 choices, and that's even or odd, so clearly this is even, right? 4 is an even number. Now, leading coefficient, right? That leading coefficient, meaning that term that has the highest exponent, what number do you have in front of it? So that's a -1, and so obviously that's negative. There's only 2 categories here. It's either negative or positive. So we go to that chart. Go to the chart from your notes, and what is the what does this tell you when the degree is even and leading coefficient is negative? It tells you that you're going to have all the x's going to negative infinity, giving you y values that also go to negative infinity. I put 2 negatives there. Okay. And it's going to also be that when the x's approach positive infinity, that the y's, meaning the f of x function, will also approach negative infinity. I put an extra negative again. Meaning that you're going to fall to the left and fall to the right. So here, I know that for all the x's that are less than -2, if I was to pick an x like -3, and if I was to evaluate my function when x is -3, I'd get a negative number, meaning I know that the graph is going to be below the x-axis there. And I also know that if I pick an x value greater than 3, like an x value of 4, and I put that back in and I evaluate the function in x value of 4, what will these y's be? These y's will also be negative, meaning the graph is going to be below the x-axis again. So I know that that's what that graph is going to look like there. Now, how about in between it? Okay, well, whenever the multiplicity of your 0 is odd, like here and here, these 2 x-intercepts, then the graph is going to cross the x-axis at the x-intercept. But for this x-intercept of 1, 0, since that multiplicity was even, see how this multiplicity was 2, since that multiplicity is even, the graph is going to just touch the x-axis at the x-intercept. All right, so let's do this one right here, the x value of 3. I know the graph is going to cross. So if the graph is going to cross the x-axis, that means that since this part I already knew was below, this part is going to be up above. Okay, now at the x value of -2, again, that multiplicity was odd, so I know that the graph is just going to cross the x-axis there. Well, that means since this part of the graph is already below the x-axis, this is going to be above. So see, I got to cross through the x-axis there. Now, this x-intercept, right, came from a 0 that had an even multiplicity. So the graph is just going to touch the x-axis there. Well, if I already know that since it's above here and it's above there, that the only way to stay above in each of these intervals is for this to turn here, and then just come back and touch like that. So there's my graph. Now, I really don't know how high it's going to go here and how high it's going to go there, so that doesn't really matter to me. But what does matter is that you only just touch the x-axis right there at the x value of 1. So if you were to evaluate, if you were to pick an x value between 1 and 3, you should get a positive y value when you evaluate your function. If you were to pick an x value between -2 and 1, and you were to evaluate the function at that x value, you would again get a positive y, meaning the graph would be above your x-axis. And there we go. All right, so let's do it one more time with number 2. Now, the example for number 2 is a little bit different than the example for number 1, is that this hasn't been factored yet. And you really do need it to be factored because you need the zeros. And it's not like I'm telling you the zeros. See, for some questions that were in one of the lesson 14 homework assignments, I can't remember if it was day 1 or day 2 or maybe one of each, I gave you a polynomial function that wasn't factored, but I gave you all the zeros. Right? So because I gave you all the zeros, really you knew where all the x-intercepts were, and you didn't actually have to factor to do it. Plus, you can always just evaluate your function by going back to this, polynomial form. You don't have to evaluate in the factored form. But right now, like I don't know the zeros unless I factor this. So I would only ask you to factor it if I already taught you the skills for doing that, for factoring. So you should be able to look at this and recognize, oh, 4 terms. If I can factor by grouping, I'm good to go. So let's see what happens if I group these two together and group these two together. So these first two have an x squared in common, leaving me with x minus 2. And then when I look at these two terms, well, if I take out a -1 factor, that would leave me with x minus 2, and yay, that's perfect. Look, I'm good to go here. See, this x minus 2 quantity is in common, leaving me with x squared minus 1 as the other factor, and then that is a difference of perfect squares. That factors even further again. So there we go. All right, so now I've got the completely factored form of my polynomial. And that tells me that my zeros, right, what x value makes each factor equal to 0? Well, this would be an x value, right, of positive 2, being setting this to 0 and solving it. Then I would have an x value of -1. And then I would have an x value of positive 1. Probably should have put those in order. So what does that mean? Okay, that means that I've got x-intercepts of 2, 0, -1, 0, and 1, 0. So I'm going to come here, and actually, you know what I'm going to do is I'm going to go 2 boxes to the number 1, 2 boxes to the number 2, and then 2 boxes to the -1, because I just don't want my paper to have to be too smushed. So I'm just going to do 2 boxes instead of 1 box, okay? So anyway, let's do the ending behaviors. So for this interval of x's that are greater than 2, what is this ending behavior going to be like? For these x values that are less than -1, what is that ending behavior going to be like? Okay, and that's determined by, ready? We got to look here. What is the degree and what is the leading coefficient? Okay, so I'm going to write here, I'm going to go ending behaviors, degree equals leading coefficient equals. Okay, so the degree, the highest exponent is 3. The leading coefficient, what's in front of it, that is a positive 1. So this is an odd degree with a positive leading coefficient. So that means that the ending behaviors are going to be up to the right and down to the left. Okay, so as the x's approach positive infinity, the function itself will also approach positive infinity. But as x's approach negative infinity, f of x will also approach negative infinity. So it's going to be up to the right and then down to the left. So if I was to pick an x value greater than 2, like 3, I would get a positive y. The graph would just keep going up. If I was to pick an x value less than -1, like -2, the graph would go down. Okay, the graph would be below the x-axis and just keep going down forever. Now, how about in between? So what's the multiplicity of each of these zeros? Well, each of these factors occurs just the one time. Okay, so the multiplicity, okay, so each multiplicity is only 1, which is odd. So back what I stated up here, that each of the graph is just going to cross the x-axis at each x-intercept. Okay, so my graph is just going to cross x-axis at each x-intercept. All right, so that means here it's just going to cross and come up. Here it's just going to cross and come down. Now, if at this x-intercept the graph has to cross as well, right, it's got to cross through and it's already down here, then it's going to turn so it can cross through it. And then again, it would have to turn here so it could cross and come back down. And then that's the end of the graph. Okay, so I really hope that this all tied together for you in this lesson, because what we're going to do next week is review and quiz out on this. All right, please message me with any questions that you might have on it, and have a great weekend. Bye.